everybody, and in this video I'll be talking about other bases other than base 2 and base 10, which we talked about in our last video. Now, of course, what we learned before is that numbers in different bases can be written differently. For example, in base 2, we learned that base 2 digits can only be 1 and 0. And the case is kind of similar for base 3. Because in base 3, there are only 3 choices for digits: 2, 1, and 0. And you can see the pattern. Like, if a number is greater than 3, it's greater than 10 base 3. Because 10 base 3 is equal to 3 in base 10. So if a digit is 3, then it's equal to 10 base 3. Which is not supposed to happen, because in real life, we don't have digits greater than 10. So we can only have the 3 digits, 2, 1, and 0. Now, in other bases, we only use other bases because it's simpler. Like, base 2 is really simple. It's like just 1s and 0, which is kind of the reason why computers use it. Now, base 3 and other ones, we just use it because it's interesting. Now let's go to adding numbers in base 3. Now, hopefully, when we do stuff in base 3, you'll understand how to do numbers in any, base. For example, base n. So, like we saw before, let's just start with adding 2 numbers, 65 and 72. Whoop. Not 65 and 72. 12 and how about 21. So these 2 numbers, let's add them together. Now we see that 2 plus 1 is equal to 3. But 3 is 10 in base 3. So this is just equal to 0. And we put the 1 up here. And when we see that 1 plus 2 is equal to 3, which is also equal to 10 base 3. So we have 10 plus 1 at the top is equal to 11. So we have that 12 plus 21 is equal to 110 base 3. And this is all in base 3. So, like we saw before, when we add numbers that add to the base, which is 3, then we have to carry numbers. So if we saw, for example, in base 2, when we saw that 1 plus 1 was 2, in base 2, since 2 equals 2, then 2 is equal to 10, and we have to carry that 1 over to the next one. So now let's start adding numbers in base n. So let's say that n is greater than 7, is greater than 2, which means that so far we only know that we can use the numbers 1, and 0, and 2. So those are the digits that we'll be using. So again, let's do the same operation, 12 plus 21. Now, we don't know actually what this is equal to because we don't know what base n is in. Now, of course, if n is 3, then that would be equal to 110 base 3. But what if it was a different base? Well, if it's greater than 3, then we know that 2 plus 1 is just going to be 3. Because 3 is still not equal to 10 in base n. So this is still going to be 3 base n, and same as this. So it'll just be equal to 33 base n. Now, what we'll see is that we can write 33 base n in base 10 as 3 times n to the first plus 3 times n to the 0th power. That's how you can write any number in some sort of base, and then convert it into a base 10. So, from seeing this, hopefully you learned something. Now, of course, this was a really short video, and I highly recommend that you watch my binary video, because this video was sort of confusing if you did not watch my video on binary. So be sure to check that video out, and make sure to hit the like button. Thanks for watching.